Hi, everyone. My name is Paul Baumgarten. Lovely to see you all here. And I'm the computer science teacher at Sharjah College, where I've been for the last 6 years. Prior to that, I taught at International School of Lausanne in Switzerland, and before that in the Australian context. And it's lovely to be here with you all today to talk to you about a book. And I'll hand over to Carl's next on my screen.
Okay. My name is Carl Turland. I'm currently teaching at the International School of Lausanne in Switzerland. I've been teaching the diploma now for 8 years, 6 years in Lausanne, and I was previously at La Rose. I've also taught in Thailand and the UK and a little bit in Indonesia as well. And Iona?
Hello, everyone. My name is Ioana Ganea. I'm Romanian. I'm currently based in Luxembourg, working at St. George's International School. I have been working in UK, Egypt, Romania, Germany, and now Luxembourg.
Fantastic.
Pleased to be here with all of you.
All right. So, yeah, we're here to talk to you about our little project we've been working on for the past year and a half or so, computer science for the IB diploma textbook. We have a few things that we'd like to get through today, probably about 3/4 of an hour or so on a bit of a presentation, and then follow up with a Q&A. So we're going to start by talking through some of the major changes of the course and highlighting a couple of aspects in the book as we offer each of those, and then talk through some key features of the book in terms of how we designed it and things that we prioritized as we're doing it. Given that we're talking about computer science, programming language, and choice of programming language is, of course, a big subject of conversation and debate, as is the new internal assessment. So we'll talk specifically about that. I know there's lots of questions about how that's going to work and how the book could possibly help with that. And then we'll finish up with a brief discussion about some possible strategies for course planning. So straight into it, we'll do a quick summary of each of the main unit topics. And A1 Computer Fundamentals, I'm going to hand over to Carl.
Okay, thanks, Phil. So A1 Computer Fundamentals, we're really highlighting, I guess, the new content here. There's a lot of content in here that was brought over from the previous course as well. Mostly the things to take note of when we're addressing CPUs now. We've got a few more registers that we need to include: the instruction register, the program counter, and the accumulator. Although, I mean, if you're anything like me, you would probably have already taught those anyway, but they're officially on the spec now. We're addressing multi-core CPUs with single and multi-core, and also how pipelining works, but this is a high-level topic only. GPU is now on the curriculum as well, with some additional parts in there for high-level students, as well as compression, lossy and lossless, RLE and transform coding are all included. On the binary side, we've got to now handle how binary works with video and audio. And then we've got different ways of representing binary as well, with gray code, fixed and floating points. Logic gates, no more symbols with and or written inside of them. We can actually use the correct symbols now. And we've got one new additional logic gate to deal with in the XNOR gate. And we've also got Karnow maps now, which can be up to 3 inputs. Finally, on the A1 section is translation, which is a brand new area as well. Okay, I'm passing over. Oh, I should say, sorry, the hours for the A1 is 11 for SL and will be a recommended 18 hours for the higher level. I will just add in there that having wrote the unit for this one, it is a larger unit than you might initially anticipate. So it is worth having a look over the amount of content that needs to be covered here. As you'll notice in the book, it does cover quite a few pages. Okay, passing over now to networks, which I think was Paul.
Yes. Also, I should just mention, we do have obviously the chat happening in Zoom. So if you've got questions, please feel free to post them in the chat. We'll try and keep an eye on it. hopefully the screen doesn't just kind of scroll too far away too quickly on us, and we'll either address them as we go or, you know, save some of them towards the Q&A at the end. So yeah, so A2 networks. Yeah, I felt this is a more thorough introduction to networks than the one in the current course, or the old course. I'm never quite sure how to refer to it now. It's about double the amount of content. So the recommended hours went from 9 to 18. It does modernize it a little bit. We're shifting away from that emphasis on the OSI model that's there in the older course to really just looking at the TCP/IP model. Personally, I found as I was assembling this chapter that I found there was a lot in common with the GCSE content. So for those of you who teach the IGCSEs prior to then going into diploma, those students will be quite well advantaged and be familiar with a lot of the content in this little topic here. So yeah, we're looking at the different types of networks, infrastructure, the different devices that are typically available on a computer network, client server versus peer models, and all the different topologies that are available. The main protocols, TCP/IP, obviously, IP version 4, version 6, HTTP, HTTPS, DNS. Each of those we look into in a specific amount of detail. There's a couple of others that kind of get mentioned along the way, but those are the main ones that you really need to focus on. The different types of transmission media, how switching and routing works across the network, and then a significant chunk on cybersecurity. So different vulnerabilities, what the countermeasures are that we could use to protect against them, and asymmetric, symmetric encryption, the use of digital certificates in providing networking security, and things like that. So yeah, A2 networks certainly a more thorough introduction there than the current course. And I'm going to hand over to Iona.
On A3 databases, standard level have 11 hours, higher level 18 hours. There are many concepts coming from option A. The ones that I have highlighted over here, databases fundamentals, database design, data warehouse mining, spatial types of databases, TCL and atomicity, consistency, isolation, and durability. Those are coming from option A. The other topics are most of them new. The point is that this time students are expected to write actual queries. So it's no longer explaining how they work or having an understanding. They need to know how to write them. As there are different ways of writing SQL statements in different database systems, they can actually use a generic structure. This topic is quite an interesting one to be brought in the core part because it does really help with the internal assessment. We have core concepts, basic SQL statements for standard level, but then they bring up some aggregate functions like sum, max, minimum, average for higher level, and the rest part of the higher level is more theoretical. They do have different views and types of databases, role of online analytical processing, distributed databases, and different types of databases. I think this topic can also be connected with machine learning well and the programming part, especially in the role of creating the internal assessment. So it's quite a good point that they brought it in the curriculum.
Yeah, I like the idea that the curriculum has moved away from the options. That was always seemed to be adding more complexity than necessary. So, all right, over to A4, which is one of the biggest notable changes, especially on the theory part of the course, introduction of machine learning, which, yeah, a lot of people are very excited about. I know I'm really looking forward to teaching this one. especially to the HL students. So I'll say right at the start, as you can see from the hours, the recommended hours distribution, it's only 5 hours for the standard level. They really just get a very surface level introduction to supervised versus unsupervised versus reinforcement learning, and then into the ethics portion at the end of the unit. They miss out on all the fun stuff. So I've actually been using that as a bit of a selling pitch to get some students, hey, you really want to be looking at high level and this is why when it comes to machine learning. So the 18 hours for the high level students. And yes, I mean, students are going to get a chance to take a look at linear regression, different classification techniques. We've got the hyperparameter and their role in tuning a network. The unsupervised clustering, we've got the association rule, we've got reinforcement learning, we've got genetic algorithms, as well as a look at artificial neural networks and convolutional neural networks. So there's a lot in here, but it's really exciting and interesting content that the students these days, they're fascinated with the machine learning. So while there's a lot in it, I think the students are going to thoroughly enjoy it. As we're preparing this chapter, we were very aware that many students are going to be coming in excited, but it's also could be a little trepidatious for some of the teachers, given that it's not in the existing course. So a lot of teachers are going to be teaching this kind of material possibly for the first time. So we've tried to structure the chapter in such a way so that it's helpful for the teachers as well who are upskilling with this content. Exam preparation should clarify pretty much at the start as well that as far as all those different algorithms are concerned, the level of detail needed for the exam, the command term on a lot of this, most of those algorithms is limited to describe. So we're not talking about evaluate, in-depth explanations of the technical inner workings of each of the algorithms. Explain the command term of explain is used for linear regression, classification, hyperparameters, and then to be able to explain model selection and comparison. So those are the only ones where you might need a bit more of a deeper technical explanation in the exam. But we are also very conscious that a lot of students are going to want to be able to experiment with machine learning programmatically. So even if just for the exams themselves, they might just need to be able to describe, say, reinforcement learning or a genetic algorithm. I know a lot of my students are going to be, well, I don't want to just be able to write, 3 or 4, a sentence or 2. I'm going to want to be able to play with this thing. So we've deliberately put in programming code worked examples for each of the algorithms for the students to have that hands-on opportunity at having a go at it. So machine learning, an exciting introduction to the course. I can just quickly see question there. Yeah, the working code is in Python, making use of the libraries available, such as TensorFlow, NumPy, Pandas, and those kinds of tools that are kind of uniquely available to Python. So that might be a factor in your choice of programming language, or you might decide to, dip between different languages for different parts of the course. So so that's A4 machine learning, and then we shift to B1, which is back to Iona.
Just to mention, I say Robert's question has come in there as well. So as I'm aware, the machine learning is the only unit we have which is only directed towards Python. All our other units are available in both Python and Java.
Yes.
Just to answer that question. And that's B1.
On computational thinking B1, both standard and higher level have 5 hours allocated. It is assessed in paper 2. The computational thinking unit is very useful for the development of the internal assessment. They discuss about problem specification, which helps in criterion A. Defining abstraction, algorithmic design, decomposition, pattern recognition. Those concepts can be applied in problem-solving techniques and also internal assessment. Flowcharts, basic concepts, they just cover the shapes and tracing, understanding how to trace a table, but then this topic is reviewed in B2, where more complex flowcharts are being traced in order to check the functionality of algorithms. It's a very small unit which can be done very quickly.
And no pseudocode.
And the programming one, only 2 hours extra for higher level, 40 hours for standard level, 42 for higher. Those 2 hours are allocated for recursion. Other than that, everything is the same. Programming fundamentals, that's everything that was in, almost everything that was in topic 4 before. We do add manipulation of substrings. Exception handling was before. Debugging techniques, that's something new. Data structures, we bring down static versus dynamic data structures, arrays and or lists in Python that covers 1D and 2D data structures. Stacks and queues. For stacks and queues, it's just the basic part, but they will be covered in the following unit. Programming constructs, selection, repetition, functions, modularization, programming algorithms. We bring big O, which was always used before in higher level to explain complexity of the programs and compare different algorithms. Now this is a requirement. Linear binary search, bubble sort, selection sort are both there. File processing, all the programming exercises in the book are covering both Python and Java. We have alternative solutions to exercises for both the languages. Now, writing programs to manipulate substrings is required. So knowing how to concatenate, replace, or alter text is important for the coursework. You do need to know how to do that for the exam. They are actually requiring you to use some functions sometimes, but other times they tell you not to use them, and that's something we will discuss in language choice.
Okay.
Okay. Object-oriented programming, the perennial favorite. Very similar to option D in the current course, but slightly rearranged, certainly in terms of how it's been split into the standard and high level. The standard level, you can see it's really only, it's a recommended time of 7 hours versus the 23 for the high level. So standard level, it's a brief look at the idea of OOP, and it, some of the terminology and the relational aspects that it empowers. But then as far as programming and, getting into the teeth of it, it's really just, it's coding up classes at a single class level. So they'll be having to work with a class, instantiate an object using the constructors, static versus non-static attributes and methods, as well as the idea of encapsulation. And yeah, using the access modifiers. And that's kind of basically it at standard level. High level is where we then have the multi-class relational and dependency aspects of object-oriented programming. So inheritance, polymorphism through overriding rather than so just overriding, abstract classes, composition, aggregation, and a brief look at design patterns as well. So, and as you can see, I've got the little note there on the slide. Yes, Python can do OOP. It just looks ugly with the double underscores. So basically, as far as using access modifiers, while Python doesn't doesn't enforce, it doesn't have strictly defined public versus private, the convention of using the underscores to indicate protected and private is sufficient for our purposes in an introductory level course. So, but yeah, this is one of those units that, like us as an author team, we were debating while we were writing this. It's how would each of us go about teaching this unit? And I think, you know, there's an argument to be made for dabbling a little bit in both languages, specifically when it comes to this unit. So like, for instance, if you're using Python for most of the rest of the course, you might still be, you know, you might still want to do a couple of lessons with a little taster of Java when you're doing this. But that's, you know, that's a choice for you and what works best with your students. Was that a question there? So I saw a comment in the IB forums that teacher said the example code for it did not follow. Well, yeah, so that comment you're referring to was talking about the use of decorators, so decorators are not, I mean, the use of decorators is to create an alternative method that kind of behaves as an attribute, which is kind of like I mean, in my view, it's a bit supplemental to the idea of having an access modifier. You know, it's the underscores are still what's doing the job of making something either visible or not visible in a quasi sense through the IDE. Yes, you can work your way around the underscores if you know what Python is doing under the hood. But yeah, for an introduction level purpose, we know which is what this course is. It's not a university level course. The underscores are going to be sufficient. So I think the idea with the IB there was just to not overcomplicate things. So okay, and with that, I'll hand over to Carl.
Yeah, so abstract data types is a high level only unit. A lot of the stuff that we've taught before in this topic is carried over. So we've still got the linked lists, we've still got our binary search trees, and we've still got the same things we need to do with them, the singly, doubly, circular, being able to kind of add nodes, remove nodes, that's all still there. So really the new stuff in this unit are now sets, and being able to use unions, intersections, difference and subsets and supersets with those. And we've also now got hash tables that have come into this as well, which I think are two good additions really into this unit. I think I'm right in saying that queues and stacks used to also exist in here on the previous one, whereas they're now, I think they're in B2 now. So they've been moved out, although obviously they'll still be referred to through the linked lists when students develop them in this unit. This is, I would say, in terms of the amount of things we have to cover, is just there's quite a bit of depth in this unit, and there's 23 hours set aside to cover the topics in here. Okay, I think that pretty much covers B4. Okay, case study.
Yeah, so just a brief mention of the case study. Everyone does it now. Standard level students get to dig into new emerging technology each year as part of the course. It's no longer just reserved for the high level students. So whether that's a plus or a minus, I guess, depends upon how you find the case study goes. We are aware that the case study is one of those things that, I mean, it can be difficult to teach. You know, it's a brand new piece of content every year, which, you know, helps make things interesting for us as a teacher because we're getting to explore something new. But it also creates a pressure because we realize we're preparing our students for an external exam on a brand new thing that we're coming across every year. And, you know, we might not be intimately familiar with whatever the topic of the case study is. And probably more importantly, that there's not a bank of past papers to be able to draw upon. So we do realize there's, you know, there are challenges with teaching the case study. So we've tried to set out a bit of a strategy, a recommended approach of tackling it, and, you know, how to make use of that time. Obviously, the focus is all on the challenges faced. So in terms of the structure of how it's split, you can see there the summary. The case study forms 24% of the weighting for paper one versus 30% in the high level. And of course, paper one is worth different amounts for each of the standard and high level anyway. So that works out to about 18 minutes of exam time, 36 minutes exam time. And then the quote unquote essay question for the standard level students is a 6-marker question. So again, the level of depth that they're going to be expected to be able to get to in that, you know, is reduced. And the standard level students just have the 2 challenges that they look at, whereas the high level students will have the same 2 challenges as the SL plus an additional 2 challenges to research into. So yeah, 15 hours recommended teaching for the standard, 30 hours recommended for the high level. But yeah, so we do have a section in the book where we go through some suggested teaching strategies, and we've gone through and analyzed, you know, a lot of the chief examiner feedbacks from previous years, and, you know, pointed out different strategies that they've suggested, and kind of tried to give you a bit of a structure from which to be able to teach the case study, given that we don't know what it's going to be every year. So
yeah, well, just to follow on from that, I was at the Cat 3 course in Vienna last weekend, and hello to anyone else who was there with me. But one of the discussions we did have was possibly that this is going to be, you know, the time associated with this now is quite a bit less. And it kind of came clear that really the 12-mark essay question, especially for the high level, is really targeting the students who are aiming for the very, very top grades. And it was kind of suggested by the curriculum manager at the time that potentially the students could answer this in kind of more bullet point form if time was against them, to try and pick up points in this section. So yeah, it'd be interesting to see how this actually plays out when the real exams come out. But I think it was definitely noted that, yeah, it used to be an hour, 1 hour paper, didn't it? So it's definitely a reduced time, although obviously with a few less questions as well.
yeah. All right, over to
Okay.
Oh.
Okay, so talking more really about the book itself now, and some of the key features that generally come with a Hachette book. So what you'll find as you're going through the book is we will include top tips. These are more kind of advice on how we feel, with the kind of tips we'd give to our students to do better in the exams. And also at the same time, highlighting common mistakes that we often see when teaching these topics. It does include some ideas on how to integrate this with TOK. And so they will link to kind of theory of knowledge, help trying to bring more discussions into the classroom. And also we'll have key information boxes that highlight kind of essential information that we feel is needed for to answer these questions in the exams. I think mentioned previously, but we have programming exercises throughout the book, not just in our programming units. So there's opportunities in A1 and A2 as well to have some programming exercises, and they're covered there as well. We also have some review questions, which is more about kind of the students being able to use them for self-assessment. Possibly could be good homework tasks that could be set after a unit has been taught. So we have some activities and some exam practice questions as well. The exam practice questions are author written, so we've done our best to try and kind of emulate what we think will come up in the final exams. And the activities tend to be kind of bigger projects that we've put into the units as well, more likely linked to ATLs, quite often paired kind of programming projects, or as I think one of the examples I've put on here, kind of creating networks and actually having hands-on electronics kind of physical projects as well have been included in the book there. So one question that I know was very popular in Vienna, we're all thinking about teaching, because I know we've all come from this from a Java point of view initially, but now we have Python on the agenda. And which one do we choose?
Before we go through this, I just want to mention that we have answers for all the exercises that we have provided in the book. Just the reflection questions. There are some reflection questions in B2 where students are required to identify if they have used the best technique, if they have reached to the solution, what mistakes they have done. Those are questions that we couldn't provide an answer to. But other than that, we do have answers to the activities and questions that we have throughout the book. I think those will be provided online.
I was going to say, I think they're downloadable, aren't
Yeah.
they? Yeah, they're not actually in the book. Yeah.
Yeah,
Now,
I believe it's going to be a teacher login so that they're not just easily available to students as well. But yeah, Hatchet will have to clarify that.
Coming to programming language choice, the course material is not specific to either programming language, so they have looked at techniques, methods to be studied, but not based on one specific language. Therefore, they are aiming to come up with questions that can be translated in both languages, coming up with 2 versions of the question in the exam paper. However, how this is gonna work, we will figure out in the future. The Python programming language, and this is an important paragraph that I have seen it several times in the guide, because Python is allowing to do things quicker, having functions that can solve programming algorithms much quicker. There are moments throughout the exam papers when they will not allow the use of built-in functions. So those instances should be clearly indicated in the exam paper. Other than that, the students should be able to use functions. For example, in the sample paper, I have seen them using the split function to split some content in a string. So, but when it's not allowed, they will be mentioning that. I think the idea behind this is that they want students to be able to put together their own algorithms and develop their logical thinking skills. SL students are able to study the course successfully with no prior knowledge, but the IB is encouraging HL students to have been exposed to some programming. And we have heard that there might be a document coming for the Python, similar to the old JETs, for the exam preparation. Another language we are looking at is SQL. Cal.
Sorry, is that another slide? Apologies. There we go.
Oh yeah, the OOP principle. We can go to that one. It's much easier to come up with or developing OOP programs in Java. They have specific keywords. Things are straightforward. Python is not looking as good as Java when it comes to OOP, at least my opinion. For exam purposes, they are using a naming convention, and what I have seen in the specimen paper, it was that underscore character, for example, is being used as a private attribute, but I have seen that they mentioned that, they have explained that in the paper. Clearly, those can be bypassed in Python, so encourage your students to stick to them and use those conventions so they are actually using them in exam. The same happens with declaration of variables.
Yeah, one of the other things that came up in discussion was obviously making sure indentation's really clear when you're writing exam papers can be a little bit more difficult with Python to show what's inside of a functional method. We have requested actually that they have grid paper on the exam paper, but yeah, I'm not sure if that will get the go ahead or not.
Yeah, that would be useful.
And then for databases, they are encouraging to use SQL statements, as they can differ from a system to another. The book is using a generic syntax that is in line with widely accepted principles and standards in database management systems, which would fit to what we have seen on specimen papers as well. So if you are using a specific software that has a specific SQL syntax, you can use that, but you can also use a generic standard one.
All right, the internal assessment. Let's see how many questions start popping up in the chat for this one.
Mm-hmm.
So just a quick high-level overview mapping the existing versus the new criterions. So the criteria A, scenario, rationale, success criteria, pretty well remains the same in terms of the main three aspects of it. We'll get into the nuance of the differences in a second. Criterion B has been split into. Sorry. Yeah, criterion B is split into two parts. So that instead of the record of tasks, which I don't know, I always found my students kind of, it was never a genuine record of their tasks done. That's been turned into a planning document as a new criterion B, and then the design document and the test plan have been given their own separate criterion C, which kind of reflects the importance given to the design phase at the moment as well. The development document, the old criteria C, and the video have been merged together into the new criterion D. So that's where your 1,000 word write-up and the video are both bundled together into D. And then E largely remains the same, evaluation and recommendations, with just a couple of little changes. So yes, thank you, Carl, if you can scroll on. So the big change that people have noticed fairly quickly is for criterion A is the removal of the need for the client. Personally, I think this is an excellent move because it removes that kind of artificial conflict that always seemed to be there. Whenever a student was actually trying to find a genuine client, a lot of the times those clients are just, they're looking for a GUI front end to a database, not 90% of the time. And so there was always this mismatch between what the client wanted versus what the students are needing to be able to produce to satisfy IB requirements with regards to the old complexity and ingenuity side of things. And so removing the client just removes that headache and trying to thread that needle there. So it allows students to just choose a project based upon what they are interested in doing, something that they're possibly interested in learning about. And so, yeah, I think that will help relieve a bit of a burden that it was a constant problem with the old internal assessment.
I know there were some people that I've spoken to who were unhappy with the removal of the client. So it was made there's a removal of the need for a client. If you still wish for your students to have a client, they still can have one, but it obviously doesn't need to be referenced at all. Some people felt it helped the students kind of stay on task and carry on with the project. So if that is the case with your students, you are still you can still get them a client in that case.
Yeah, there's no reason they can't talk about, hey, as part of their rationale for why they're producing their project. Hey, I'm doing this for a friend of mine. Yeah, absolutely. So, all right. So the new criterion B, planning, it's only 150 words. There isn't really an emphasis on having to produce written material here. It is mostly about through diagram, either a really detailed Gantt chart, or you could do a table with some dot points, as you'd see through the sample materials being that are already available through the IB, or the full set of sample materials. I believe they're coming out on the 27th. So the plan, we're looking at addressing the requirements of the solution and providing a chronology. So personally, I'm just going to be encouraging my students to do a really detailed Gantt chart going through the steps of the design cycle process for each of the key phases of their project, which I've got a screenshot in a second. And the other part of planning is to do a decomposition, which is, it's a fancy word for a brainstorm. Take their project, break it down into the main chunks, and show that they've put some thought into, well, what are the different components I'm going to have to build and create for this project. So I think on the next slide there's a couple of screenshots from the book where we've got a Gantt chart kind of working through each of the key phases there. So a couple of requirements, and then a decomposition presented in the form of a structure chart. A couple of diagrams like that, and that's your criterion B largely done. Like I said, it's only 150 words. There isn't really much need for written text. The diagrams are intended to be sufficient for this.
The other thing to note, I think, with the planning and the Gantt chart, these aren't like the record of tasks, which are expected to kind of be continued throughout the project. these are expected to be completed prior to development now.
Correct.
So it really is just a plan that you're setting up.
So then criteria C. This is the design portion of the current course from the old criterion B. We noticed as we were going through this and preparing this section of the book, a really increased focus on testing. So the new test plans are more important in terms of a higher level of expectation, I guess, than the current level of test plan. So the teacher support materials that will be coming out soon, those referred to expectations of both functional testing and structural testing. So functional testing, taking your entire project and testing out those key features, which is kind of largely what most students do for the current testing plans. They go through their success criteria and kind of show how they're going to test each of them and what a successful test would look like. But then to add to that, structural testing of the individual algorithms and subsystems within their project. So, for instance, when we were discussing this in the Hong Kong training a couple of weeks ago, we all pretty well coalesced around the idea of we're going to make our students all do unit tests for this as a industry standardized way of being able to do that individual algorithm testing. And it's a healthy thing for students to learn to know how to do unit tests as well. So we're going to be looking at kind of a more detailed set out of test plans there for criterion C.
Carl, if you don't mind, there is a requirement to go backwards one slide.
We actually have a.
There was a question just to go back. I'm guessing someone wants to grab
Yeah,
a screen of the graph.
All of these, I say, the recording will be made available to everyone afterwards if you have missed anything.
Yeah.
Okay.
And yeah, I think there was a comment in this also about sharing the slides, which Hachette will organize as well. So criterion D, the current criteria C merged with the video. So complexity and ingenuity, those two words are no longer in the internal assessment guide. The way it has been written up is to emphasize that the focus is on implementing algorithms. And I think that that's an important clarification, because there was always this debate about what counts as a technique. If I'm calling an API, can I call that a technique, and is it complex? So the syllabus is now making it clear that when we're judging this, this 12-mark section here, the focus is on implementing algorithms. So we're looking at evaluating the choices that the students have made in terms of how they designed that algorithm, and then that they've adequately tested the algorithm. Is it performing and doing the task that they have intended for it to do? And is it working correctly with, with catching erroneous data and, false inputs and things like that? And so then merging the video into this section as well. The video is where is similar to the current video. You provide your high-level evidence of functionality. Hey, here's my project. Let me give you a quick demo. You can see that it's doing all these different tasks, but also a brief look at the testing of your product within the video. So that's our new criterion D.
And just to also jump in here at this, I said we were speaking a lot to Tim Knight about this at the weekend, and he made it very clear that this is a chance for us to kind of reset the expectations on what we have for an IA. And he really stressed that to achieve a good grade, you shouldn't need to go beyond the skills taught on the course anymore. But this does require some buy-in from us as the teachers as well, to not kind of create another monster that, like what happened with the previous course. I think we have to put a bit of trust in that these are going to be moderated fairly. We don't need to go over and abroad like we have been previously, and trust that they will moderate them correctly in that manner. I think it's really important that we do that with these ones, so we don't end up with these ridiculously long IAs, which we've had for a number of years now.
Yeah, yeah. Yeah, it had turned into a bit of a behemoth. So yeah, a bit of an opportunity for a reset is nice.
Yeah.
So then criterion E, the evaluation, largely the same, but obviously without the client providing feedback means there's a small little bit of a nuance shift. And yeah, so the idea of improvements and the evaluation part is basically solely judged against your success criteria. But there's no reason that, like, if the student has written a project that that can be used by others, that they could get some target audience feedback and use that as part of their evaluation if they wanted to, that kind of thing. So but yeah, the evaluation stage hasn't changed very much.
Yeah, the areas of improvement came up in question a little bit in terms of the teacher support materials that we saw indicated now they should be based off failed tests rather than, previously it was to not be connected to the criteria for success that had already been set up. So I'm still waiting for a little bit more clarity, I think, on how that's going to look in the final version, but hopefully they'll get back to us before we having to worry about any kind of submissions for that.
Yeah. What else? Oh, that's right. Yeah. So for each of the criterion in the internal assessment, a few little things that you will find in our book. We've ended up with I think it's about a 40-page chapter for the internal assessment. And that's largely because we know that, in the discussion forums that we're in, we see every year when the moderation feedback comes in that there's always this debate and discussion, and that it's a source of stress for teachers every year. And so we've aimed to provide as much guidance and help as possible. So we have several exemplar student work samples scattered throughout this chapter. Lots of pages that are just full of student diagrams. We've put top tips and common mistakes for each of the criterion, as well as having assembled a detailed checklist for both students and teachers alike. So I think there's a couple of screenshots coming up that kind of speak to some of this. But yeah, with the student exemplars, yeah, we very intentional to have a substantial collection. So both at the start of the chapter, I think there's about 10 pages where we just go through, here are some example student projects that have succeeded highly in the past. Partly just as part of the ideation process, helping students come up with some different ideas as to the kinds of things they could produce, just to kind of break out of the template mold that some students fall into. And so, you can see here some screenshots where we've kind of got a one-page summary of different projects that some of our students have had success with in the past. And then on the next slide, you'll see examples of diagrams. I think these are largely from the system overview, or what's currently the design phase. The types of diagrams that students have produced for that criterion. So yeah, our intention is hopefully teachers will find this fairly large chapter to be a helpful guide for them and their students through the new IA. So the question about the TSM, yeah. So my understanding is that the IB's samples and the full TSM is scheduled. So in the Hong Kong workshops a couple of weeks ago, they were saying March the 27th is when the remaining materials were going to be published. Because at the moment there's on the web page that's got the guide, it's only got a sample paper. It doesn't have the sample IAs yet. So yeah, I believe it's coming out in a couple of weeks.
Yeah, I think they've completed them. They're just translating them into French and Spanish as well before they can be published, I think.
Yeah. So yeah, we're going to have a brief look at some overview course planning and then go into a Q&A. So this was a hot topic of discussion in the Hong Kong workshops, was just the complexities around scheduling the course, specifically the split between the standard level and the high level. And it really, I mean, it's hard to kind of provide a this is the best way to do it approach, because it's going to be very individualized based upon your context, your timetable, and the guidelines that your school gives you to work within. Where it's going to be a challenge is if you have a fixed structure where you must do something like 3 SL lessons per week, 1 HL lesson per week, and so you're having to kind of split teach across, 2 different topics at once. Because the current course, we've got the old Unit 6 and Unit 7, which are, theory topics that are HL only. So previously I've been, at the start of year 12 or the start of year 1 diploma, I would be teaching those theory topics to my HL students while I'm using my SL time to get through the introduction to programming, so that I can then, shift the HL into some of the HL programming afterwards. It's going to be more challenging to do something like that with the current course, because there aren't really any theory units, so none of the A units that are solely HL. So there's a couple of different options. Some of these are ideas that came up again in the Hong Kong workshop. So if you've got HL, if you've got the flexibility to be able to set course prerequisites, you could say, okay, if you're going to do HL, you have to have pre-existing programming skills, and that might allow you to then be able to jump straight into B3 and B4, where there's, all that bulk of HL programming content. You could, I know one of the schools that I work closely with here in Hong Kong, they're toying around the idea of doing some of the B4 theory, so the abstract data types, do the theory part of that at the start while their SL lessons are doing the intro to programming, and then return and do the applied part, the programming part of B4 again later on. Another option is you could take the HL lessons to, if you wanted to start with a theory unit, A4 is probably really the only choice, because it's only got the 5 hours of SL. The bulk of that time is HL. So you could work through that with your HL lessons while you're using your SL time to kind of get the introduction to programming done. So yeah, so the next slide I've got, yeah, kind of how I'm planning to tackle it or trial it with my course next year. So the way I'm describing my strategy is I want to front load the programming. And I do this for a couple of reasons. I want to get the IA started early because, IB intentions aside, the IA is still a large thing. It's still 30 hours of class time. And I want to give students the maximum amount of time for dealing with it, especially, we all have some students who are slow to finish their IA. So I want to get that IA started in the first year, and try and get a lot of the heavy lifting done before all of their other IAs kick in. And I want to be able to give my students the option to be able to spend their summer holiday getting some of that programming done. The other thing I like about the idea of front loading the programming, so starting with all the B units, is I want to integrate as much programming exercises as possible when I'm teaching the A units, the theory topics, get them to do some programming with some networks or some databases and some machine learning to help bring those topics alive. So if they've already got their foundational programming skills, then it gives me the option to be able to do that. You'll see on the structure that my proposed timeline that's on the next slide, the one thing I'm least happy about is that it leaves the case study until after my mock exams. At the moment, I'm kind of resigned to the fact that that's probably the way it's going to be. Something's going to have to be there. Like the current course, I can largely get done and dusted before the mock exams. I don't anticipate that that's going to happen with the new course. I'm going to be teaching in February and March, because there is more content in this course. So yeah, you can see there's my timeline. Get started with some programming, get that B content done, and then finish off first year with the internal assessment class lessons, and then when we come back after the summer, go back and do the fill in all the A units, the theory content, but inserting in as much programming exercises into those as possible. So it's a draft timeline, very much still a work in progress, but this is kind of where I think I'm likely to head. And then I believe Iona's got her version of a timetable up as the next slide.
Yeah, my version of timetable is based on having 3 hours ASL and 1 HL per week. I'm starting with computational thinking, then programming, and in parallel, as you said, I'm just trying, I'm gonna try A1 computer fundamentals, those, because I thought they already have some understanding from IGCSE as well, so I could make some connections there. And B2 programming, which are only 2 extra lessons compared to SL. Finishing by December the programming part and moving into abstract data structures and databases. OOP by February, then going into March, computer fundamentals. April, May, networks, and then in May I want to start internal assessment for the same reason. I have here 19 hours of internal assessment. I would leave the rest towards the end of not really the end, maybe December, January of the following year, so they can actually have the project finalized. And then in DP2, second year, I'm looking at machine learning, again, some internal assessment, the case study, and my mocks are in December. So I have brought the case study forward, trying to fit it in the mocks as well. And then going back to object-oriented programming. The problem with 3 hours of SL and 1 of HL, it does not give you the time to cover all the HL topics. So I probably will end up having SL students doing revision and me continuing working with HL students on the remaining topics, which is not ideal, but I don't see any other solution for now.
Yeah, and for me, I'm sorry, I don't have any graphics for mine. I was really looking over it over the weekend, and I've pretty much come to the same conclusion, to be honest. My plan is really to focus on the theme B in the first year, but also include databases due to the need for them, but potentially at IAs. And then in the second year, with a real focus on A1, the computer fundamentals, the networks, and the machine learning, and the case study. I am concerned about time. I've always found like the current course is I've got more than enough time to do everything. My biggest concern is I'd kind of like to stay with Java to some extent, but trying to transition my students to learn Python before entering the diploma, and the transition from that to Java, I'm worried about the amount of time that can take. So I'm actually potentially thinking in my first year of teaching this, I will just go with Python, just to get a kind of gauge of how long I need for the other topics, because that will cut down a lot of the intro kind of programming that otherwise I would need to do.
Yeah, and that's I guess part of the pragmatic choice of, you know, what in terms of things like language choice as well, is not necessarily just from a purist, what do I think, you know, is best, but also pragmatically what's going to give me the most time back as well. And yeah, Python is definitely going to be the quicker option. But yeah, it's a tricky one, because there are merits to Java as well.
Yeah. My other concern as well is if the papers do stay the same in the paper 2, is, you know, if I was doing a coding competition, I would write Python because it's faster for me to write. And I do wonder if in the exams, that's also going to be potentially the case, that you're able to answer questions faster with Python syntax.
Yeah. So yeah, I think we're shifting into a bit of the Q&A emphasis now. So first question, when you cover programming in OOP, mostly in year 1, that students forget many of the complex concepts after DP1 and you have to review. Yeah, I mean, yeah, it kind of, I guess it might depend a little bit on what they've done with their internal assessment, because hopefully students have used their OOP within their internal assessments as well. So like I find the internal assessment is a good opportunity where students really get to crystallize a lot of their programming skill. So you know, if they've had to they've implemented several classes and they've got some dependencies happening there, then that kind of gives them a good foundation for that. But yes, you would. So like for me in the current course, so my current year 12s, for instance, yeah, we're doing OOP, so we're doing Java, but I'm also aware probably 3/4 of the class are probably going to use Python for their internal assessment. So I am absolutely going to circle back and give them, you know, I've got some lessons blocked aside in year 2 to kind of to basically remind them how Java works and go back and recover some of those concepts again, because it would have been so long since they've done it in Java.
And just to add, when we say bring the programming at the front of the course, we don't give up on the programming. We do that throughout the course. We just connect it with theoretical concepts.
Yeah, and DP2, I also find it shifts a little bit. You know, the early stages of the course, it's very practical, digital, hands-on. Whereas as I start moving into kind of DP2 and towards the revision stages, it becomes a lot more paper tasks and moving away from the laptops to kind of more exam preparation.
Yeah, practicing programming questions on paper.
Yeah.
Yes. So yeah, please post questions into the chat. Carl said something.
Yeah, so about students not going beyond the syllabus content for the IA. What I said earlier, if this is the case, it sounds like the expectation for the IA are going to be much lower. Yeah, close to 100 hours on it. Yeah, and I think it should be. I think still to score the top grades, there's going to be a difference. But to score, you know, a reasonable grade, you know, I would assume within the 20s, there shouldn't be any need to really go beyond, you know, what is taught on the course. And I say Tim Knight really made this point quite clear on our conference the weekend. That should be the case.
Yeah.
Obviously, it's going to take a little bit of a risk on our part to do that. I mean, even myself would be concerned that, you know, if I do this, it's going to be marked down. But I feel like we've got to put some trust in them. Otherwise, we're going to end up in the same situation again.
Yeah, and I think, I mean, part of the thing was people kind of obsessing over the idea of chasing high complexity. But even with the current course, like if it's still perfectly possible to get a 7, you know, with if your criterion C was marked at the top of the moderate band, you know, provided students put sufficient effort into their documentation. So it's yeah, it is one of those things there's going to be a bit of an adjustment period, but I think shifting the focus to be more specifically about algorithms will help, and yeah, but yeah, I think one of the other things as far as the complexity was concerned is I know a lot of anecdotally it seemed a lot of people were kind of conflated the idea of a large project as being a complex project. And so that's one of the things that we emphasized in the internal assessment chapter of the book, that, you know, for instance, GUIs, you don't need to write 20 different screens or, you know, things like that. If you're wanting to, you know, under the current course, demonstrate the quote unquote technique of making a GUI, which, I mean, doesn't have a lot of algorithmic basis to it anyway, you know, other than your validation techniques and things like that. You know, 1 or 2 screens gets that job done. It's, you know, so making 20 screens is kind of superfluous effort as far as what skills you're demonstrating. Now we're just looking at the questions in the chat.
I haven't been using Anaconda for quite a long time, actually. I see someone else, we're using Anaconda for Python. What about you two?
Yeah, I don't know.
You're looking at the network question, Paul? Is that the one?
Yeah.
I've played around with PicoCTF. I mean, there's definitely some good programming activities through that. I've played around with some of the Python activities on there, which are quite nice. I don't know from a network security point of view, personally.
Would you have time to do all those with the new curriculum?
Yeah, time constraints could be an issue, wouldn't it? If they're not completely directed towards the course. Could be a nice little homework task, so if students are interested in it, to take them further.
Any other questions?
Can't see any new ones now. I think we've answered everyone's.
Not a question, just a comment. Format of the exam sample paper much closer to A level. So
That's right. Yeah.
Yeah, I think especially at the start, like you said, when there aren't the past papers, those A-level resources could come in quite handy.
And also looking at option past papers for databases, for programming.
Yes. Yeah, the past papers for both databases and OOP will come in handy.
Yeah.
Yeah. The question about SQL, I mean, so for myself, I'll probably just use SQLite with my classes. And then if it's students wanting to use a networked SQL, as for their internal assessment, then Postgres or MySQL would be fine.
I mean, for data sets, I use Kaggle a lot. They've got some really nice data sets on there. That's I'll put it in the comments if someone's not sure how to spell it. It's .com, isn't it? Kaggle.com.
Kaggle, yeah.
Yeah.
Teacher version of the book. The book is the book. it is the only version of that. The main thing is on the Hatchet website will be the answers to all the exercises and the exam prep questions and all that are in the book, and the programming exercises and whatnot. So yeah, the answers is the main additional resource that is supplemental to the book itself.
Someone said about generating data sets with ChatGPT, but yeah, I think that would be a good idea as well. I mean, it would be more than capable of being able to do that.
All right, we'll just give it another few seconds to see if there's any final questions that come through. So the book is available as an e-inspection copy online on the HODL website. I did post the link in earlier on. I'll repost it now.
There you go. It's just gone in again.
Okay, cool.
Yeah.
And if you have any problems with that, like I think someone at the Hong Kong workshop again mentioned that they had some problem signing up or something. Either you get in touch through the contact page on Hatchet, and they'll be able to sort that out.
Someone's asking about a certificate for this meeting presentation. I don't think there's anything, because I'm aware that it's available. Not that I know of, unless the people at Hatchet has set anything up, but not that I'm aware of.
Yeah. And then, printed versions of the book will be shipping in about a month's time, which I am very keen to get my hands on.
Yeah, and we hope you like it and you all find it very useful with your teaching.
Yeah. Any final questions? Otherwise, we do appreciate you all putting the time aside to join us here on Zoom today. thank you for joining us. And yeah, we hope you find our book useful.
Yeah, and thanks to anyone who's listening on the recording, I guess, as well, because I'm assuming
Yeah.
it probably wasn't the right time for everybody. So yeah, and good luck, everyone.
Good luck. Thank you, everybody. Have a lovely day or evening or whatever is ahead of you.
Thank you.
Thank you. Bye-bye.
Bye.
Bye.